Marks and channels, visual marks and visual channels. This to me is the bread and butter of data visualization because it helps you map those attributes based on what their type is to the graphics on the screen, and it provides sort of a systematic way of looking at this decision space. We'll discuss marks. What are marks? Points, lines, and areas are the marks that we'll be dealing with. And then what are the channels? Channels include position, color, size, and shape. And again, this taxonomy is derived from Tamar Munzner's textbook, Visualization, Analysis, and Design. There are various taxonomies that are like this, that have slight variations that people have done over time. So this is by no means a de facto standard. It's just sort of my personal take on marks and channels. And so the idea is how to choose marks and channels based on your attribute types in your data set and the tasks or your goals or your direction. So marks include points, lines, and areas. And surprisingly, a lot of visualizations can be boiled down to these marks. And then channels are modifiers on the marks. So for example, position, X and Y position, X position being from left to right, and Y position being from top to bottom. Position is the most powerful channel because where things are on the screen is what you perceive first. It sort of precedes all other perceptions. And so that's position as a channel. Then you've got color. And color is actually kind of subtle. There's actually 3 separate dimensions of color. There's this one, which is hue, which is the place around the color wheel. And then there's saturation. How far away from grayscale is it? And then there's luminance. How far is it from between black and white if you were to sort of apply a tint to the black and white grayscale? So these are 3 sort of elements of color that we have to deal with. And again, there's so many models, color spaces and color models, but this is my personal favorite, and it applies to visualization. Hue, saturation, and luminance. And I think there's a couple implementations. There's one in D3. It's called HCL, I believe. So that's the nice color space to use. And then we've got size. Various marks can have various sizes. So size is another channel, and shape is another channel. And position, color, size, and shape have sort of different places where they could be applied depending on the attribute types. And we'll get into that. So consider this table. It's I believe, the miles per gallon data set from UCI machine learning repository. The idea is that rows of the table, in this case, particular models of cars, correspond to marks on the screen. And then columns of the table, like miles per gallon, cylinders, displacement, horsepower, these map onto channels. And taken together, the mapping of rows to marks and columns to channels forms a data visualization. For example, consider this scatter plot. This is a scatter plot of the same data set we were just looking at. Each point represents a type of car. The marks here are points. And the X position is driven by a quantitative attribute, namely displacement. Yeah, displacement here. That's the quantitative attribute that drives X position. And then Y position is driven by another quantitative attribute, namely horsepower. This goes to show you that X position and Y position can be mapped from quantitative attributes. So anytime you have any quantitative attribute, you can assign that quantitative attribute to X or Y. And in the D3 world, you'd have to use a linear scale for this, or maybe a log scale if need be. But linear scales and log scales is what you can use to assign the values from quantitative attributes to X and Y position on a graphic. Now consider this scatter plot. I just want to point out that you can vary the subtleties of the aesthetics of the marks, and it's not going to change the fundamental visual encoding, which is the mapping of rows to channels and columns to marks. So this is where you can get sort of artistic. You could do something like change the transparency, or change the size, make them all the same color, put a gradient there. Anything that's not data driven, you can do to your heart's content and make it very aesthetically pleasing. And making the marks semi-transparent like this, I like to use this in practice to show density. Because see how these things overlap? This area here, right here, is very dense. And you wouldn't be able to see that if you didn't use this semi-transparency. See, it's not as easy to see right now. And so that's the value of using semi-transparency, or adjusting the opacity of the marks. So you can see, sort of a side note. So yeah, scatter plots are essentially points using quantitative attributes to map onto X and Y position. You can also use hue. So notice that this one uses hue, which is a part of color that determines its position around the color wheel. Oh my gosh, wait a minute. I think I found a bug in my slides. Hold on, I have to fix this. But this is using hue not to represent a quantitative attribute, but to represent what type of attribute is origin of car? Somebody tell me.
Categorical.
Yeah, categorical. I had a bug in my slides. This scatter plot here uses hue in addition to X and Y to represent a categorical attribute, namely the origin of the car, Germany, Japan, USA. And this is sort of representative of hue, because hue maps really well onto categorical attributes, because hue, like categorical attributes, it has distinctly different values, and it doesn't have a natural ordering that you can perceive with your visual perception system. Arguably, there's a natural ordering along the spectrum, the electromagnetic spectrum, but our eyes are not tuned to receive that as something that we can say, like red is less than yellow. Like I don't know, is red less or more than yellow? And it doesn't really matter, because hue works best with categorical attributes. So yeah, that's a point I wanted to make. Consider this scatter plot. There is size in use here. The marks are different sizes depending on the weight of the car. So this is a visualization. This is a visual encoding that handles 3 different columns. And all of those columns are quantitative with X, Y, and size. But how do you really implement size? This is where it can get tricky. Like if you're implementing size on circles, how do you set the radius of the circle? This is something that a lot of people get wrong, because the way that people perceive size is based on the area of the marks, not the radius. The radius is proportional to the square root of the area, or something like that. And so you need to take that into account when you map data values onto size. So from an implementation perspective, like with D3, you would not want to use a linear scale to map values to size, because then the area would correspond to the square of the value, not the value itself. And so you'd have things that are out of proportion. It would be sort of misleading. And you also must use a zero baseline when you do this conversion, because I've seen people make scatter plots where something that has a value of 0 is a small dot that you can see. But in my opinion, I'm very opinionated about this. If the data value that you're using to drive size is 0, then you shouldn't show anything because the area would be 0. And if you do, it's sort of cheating. So that's my take on size. That the area of the mark should correspond to the value that's coming from the data. For completeness' sake, I included this scatter plot to say that you can make a scatter plot that's driven by 4 columns of the data, 4 different quantitative columns. Oh no!
You have the same bug.
The same bug is here. Oh my gosh. Yeah, so hue is mapped up to a categorical attribute. This scatter plot is driven by 4 attributes. 3 of them are quantitative, x, y, and size, and then there's a 4th categorical attribute that's being mapped onto these marks using the hue channel. This scatter plot uses hue to represent year. And you could treat year as an ordered attribute because they have different values and they have a natural order in between them. But it doesn't really make sense. I would not recommend this. I would not recommend this at all because year has a natural ordering. I mean, ordered attributes in general or quantitative attributes have a natural order in between them. And so using hue to map onto something that does have a natural ordering, it doesn't really make sense. It doesn't make sense. You'd be better off using luminance to encode that because it has a natural ordering to it. So this works with ordered or quantitative attributes. But luminance maps very well to ordered or quantitative attributes because it has a natural ordering. You could say this mark is lighter than that mark, which could correspond to a statement in the space of the data where you could say like this year is earlier than the other year, or that population is larger than the other population because it's brighter. So yeah, this mapping of luminance to a quantitative or ordered attribute is very powerful. And that's how I would recommend using color to encode ordered or quantitative attributes. And hue should be mapped onto categorical attributes. Here's an example that maps an ordered attribute, namely the year, onto the X position. And this further demonstrates that X and Y position are the most powerful channels. Powerful in the sense that you could map any type of attribute onto them and it would still work. So this is sort of an example of position encoding an ordered attribute. Position can also represent a categorical attribute, and here's an example. There's nothing stopping you from doing this. Germany, Japan, USA are arranged in space along the x-axis. So the take-home point of all this is that X and Y position both could be mapped onto any type of attribute. And so when you start exploring data for the first time, I would recommend making scatter plots and just changing what is X and Y position and try out a bunch of combinations. And then from there, it will become clear like, oh, maybe instead of using X, I should be using size or luminance or hue to encode the attributes. And then we get into the visualizations whose mark type is line. Line charts. Line charts, it's a very powerful class or genre of visualizations. You can show so many things with line charts. And there's sort of a convention, or the most common type of line chart that I see is line charts where the x-axis represents time. But yeah, getting down in time resolution, the more fine points in time you have, the more it makes sense to treat it as a quantitative attribute. And that way you can just plot it along an axis like this and come up with, for example, line charts. And by the way, you could, I don't have the example here, but you could take each data point and put a circle there. And so that way you could add points as like an overlay to a line chart, and that's powerful because it can tell you where the actual data points are and where they are not, where the line might be interpolated between them. here's an example that uses size as well to represent a quantitative attribute. And I want to point out that this is kind of problematic because size is often interpreted as like an absolute quantity as opposed to a relative quantity. And temperature is a perfect example of something that is relatively defined. And so using area in a case like this, I would argue it's not a good idea because the area under the curve is not readily interpretable. It doesn't really make sense to measure the area under the curve for a given instant in time and be able to say something about it. It's, how many degrees warmer was it from 14, which is just totally arbitrary. Doesn't make any sense. So when you're doing visualizations with area, I would say it makes sense to have quantities that start at 0 and also have a 0 baseline of the visualization, like this example here, which is the population of the world since 1950 to, I think, 2015 or so. And I want to take a step back and look at this particular visualization. I find it totally fascinating to just think of this, that our species has been on Earth for, who knows how long, but our population has more than doubled since 1950, just the past 50 years. So I don't know, it's just a mind blower for me, this visualization. It's a mind blower. You can also use areas to represent multiple different things, and you can distinguish them using hue. For example, when there were pretty much 0 CO2 emissions. And so you can see that, like, following the chart 1840, 1860, up until the 1920s, the only emissions seemed to be solids. And then liquids and gas, and then cement production have increased over the years. But anyway, this is an example of a visual encoding that I would call it a stacked area chart. It's using areas, it's stacking them, and the height of the area at any given moment, at any given position along the x-axis, represents a quantitative attribute. Now, is there any bug in this slide? Apologies, folks. But it might reinforce the point that hue, here, it maps onto solids, liquids, gas, which is a categorical attribute. Yeah, hue is mapping onto a categorical attribute. The Streamgraph technique, which is a variation of stacked area charts. But yeah, I love this technique because it makes it more readable. The way that this technique works is that there's an optimization algorithm that's in place to minimize the wobble over time of these areas. And one problem that you run into with stacked area charts is that sometimes the distortion, sometimes there's significant distortion from the bottom layers that propagates to the top layers that makes it difficult to read. And so that's why the Streamgraph technique was invented by Lee Byron. This link goes to the paper about it if anyone's interested. Yeah, it's a very interesting piece of work that Lee Byron did with Martin Wattenberg back in some time ago. Oh, 2008.
I think the thing I would also add to a lot of these is that what decisions you might make will also depend a lot on, is this something you're making for a static visualization that will be printed out or something, or just like an image, or is it part of an interactive where people can mouse over parts of this and like highlight, like maybe I would be able to like move my cursor over Sudan in 2010 and it would actually have a little pop-up that would tell me what those numbers are, so that the visualization is, the role is to show you the overall experience, and then it doesn't have to do everything. It's just like, this is your context, and then you can drill in and like get little bits of information if you need to get accurate numbers. And I think that also, like, especially if you look at some of maybe like kind of older research on visualizations, or from my point of view, like older like maps, like a lot of the lessons that we maybe have from like 20 or 30 years ago are all about like, how do you make something that people can put a ruler on this visualization that's printed in a book somewhere and actually measure a value off of it. And we don't have to support that type of thing anymore because we're making things that are online. And instead of a ruler, you've got like a pop-up, or you've got some other way to like filter that and say like, only show me the Iraq deaths, and then the rest will go away and Iraq will recenter. You know, there's like all kinds of ways where you're thinking about like, what is the overall impression, but then totally this other realm of like, how do you get the real accurate numbers out of a visualization?
Totally. And that leads me to this example, which is a great follow-on to that. I totally agree. I mean, that's all definitely true. We live in a digital age, and the first visualizations were made for print. There's a rich history of data visualization. But that particular stream graph is something I made as a prototype when I was doing some work with the United Nations Refugee Agency, UNHCR. And this has some interactions where you can hover in these linked. Well, let me first introduce some context here. The stream graph on the top is the origins of all these different population types combined, including refugees, returnees, internally displaced persons, returned IDPs. I think that's returned internally displaced persons, others of concern, asylum seekers, and stateless. And by the way, this is all interactive, so you can toggle these on and off. But anyway, on the top, it represents origin countries, and on the bottom, it represents destination countries. And as you hover, the bar chart on the right gives you a different representation of the origin data for the hovered year. So if we're looking at, for example, 1990 right now, notice that in the stream graph, Afghanistan is largest. And also on the bar chart on the right, Afghanistan is also largest. And so this goes to show that you can take a slice of time from a stacked area chart or stream graph or even a multi-line chart and feed that into a bar chart, which can represent one instant in time. And then you can link them together with this type of interaction that will let you really explore the data pretty deeply. And then you can actually click on one of these, like let's look at Iraq. And then there's this context view that lets you zoom in time. And so you can interpret this to say, where did all the well, let's just look at refugees. If I just turn off everything except refugees, now I can say, most of the refugees who left Iraq in 2007 went to Syria and Jordan. And I just love how the visualizations correspond to, facts and figures that you might hear in headlines, but you could just read them right off the visualizations. Pretty powerful. And then if you click on, let's say, Syria on the bottom, this just represents the flow of refugees from Iraq into Syria. And then if I click on Iraq on the top, it should go back to the full view. And then if I click on Syria on the bottom, oh, it looks like, most of the people came from Iraq. And then where are all the refugees from Syria going? And this only goes up to 2016. But you could say they're going to Turkey, Lebanon, Jordan, Germany, mostly. Yeah, this was a fascinating project to work on. And if we look at refugees coming into the United States, this is fascinating. It shows you that their data tracking just wasn't that good until 1980, let's say 1988, when they started really tracking this data. And you can see periods in history where people came from different places into the United States as refugees. Fascinating. So anyway, that's a little detour into a project I did where we used Streamgraphs and had these interactions.
Did you build that with D3 as well?
I did. This is built with D3, and in fact, it's open source. Oh man, that was awesome. I love following these threads that come up. Any questions at this point? I mean, we talked about a lot so far.
Given the data of like migration inflows and outflows, how did you decide to use a stream graph?
Yeah, that's a great question. So how did I come up with this particular way of doing it? It was an interesting point in time where I became sort of obsessed with this technical problem of placing labels on top of stacked areas. And so it was very, very much dependent on the circumstances of my interest in this particular problem. And so I made this library for placing labels on these stream graphs. And then at that point, I was a person with a hammer looking for a nail, and the hammer was the stream graph technique. And so I did a bunch of different stream graphs, and I went through like a couple months where I was just like, whoa, stream graphs, this is like the end all be all of Datavis, and like everything should be a stream graph, you know? Because once you get it working for one thing, there's so many other ways that you could use it. And I at this point, I would like to bring up this one example. Let me see if I can find it. Yeah, Trump topics stream graph. So this is a visualization of a data set from Google where the size is the search interest, or some kind of metric that Google came up with. But you can use this to pretty much follow the news. So this is 2017 January, the Women's March inauguration crowd sizes, travel ban and protests, Michael Flynn quits, and you can use it to follow essentially the news. And it's been always like a dream of mine to make something like this that updates every day that you could check in. I haven't got that working, but it should be feasible. It should be possible. So yeah, this is funny. The mother of all bombs was dropped. What's it? The 13th of April. So it's a very versatile technique, this stream graph idea. And so it just so happened that I was working on stream graphs at the time when I got this project with the United Nations. And then I just decided to make a prototype, which is this one here. And I showed it to them, and they liked it. And I said, well, I have some ideas where we can go with this. We can make it more interactive. And I was really into linked views at the time, so that's just sort of how it came about. And so what I did is I sketched out some of the things. Yeah, so my point here is that visualization projects often begin with a rough prototype of something based on just trying some idea, and then getting feedback on that from the stakeholders who have the questions and tasks and the direction they want to go with this. And then from there, listening, reading into what they're saying about what they want to be able to do, I just think of like, what are all the possible combinations of visualizations that would help answer these particular questions and let people carry out these particular tasks. And so in this case, one of the questions was, I believe, how do I see for a particular country, where did the refugees go from that country over time? And then in my head, I'm thinking, oh, you could make a stream graph of that, just filter the data before you'd render it. And then how do you select countries? Well, you could have a stream graph representing all the countries that could be used as a navigational element to control these filters. And so I sat down and sketched this on paper, what I thought it would look like, where you'd have a hover to select a year, zoom by brushing, select a subset of population types. And then I worked with a designer who came up with the pixel perfect mocks with the colors and everything. And then I used D3 to just, plow through these features and implement it and get it working. So I hope that answers your question.
Yeah, thanks for walking through that. That was really helpful.
Cool. Yeah, my pleasure. So yeah, that's the stream graph technique. You can represent the same sort of data using a line chart with multiple lines. So this visualization uses the line mark type, and it has multiple lines that are distinguished by hue. And in this case, hue, this is showing the flu cases in the US over time. In this case, hue maps onto year, which is an ordered attribute. But does this make sense? I mean, does anybody see any problem with this? It makes people think that they're different categories that come from a categorical attribute. But they're not. They're different years that come from an ordered attribute. Years have a particular sequence to them. Therefore, I would argue it doesn't make sense to do it this way. It does not make sense to use hue to map onto an ordered attribute. Much better to use luminance. This visualization shows the same data, but it maps year onto luminance instead of hue. And I would argue this is a much better way of doing it, because you don't need to constantly consult the legend to know what are the most recent years, what are the least recent years, because you can say the following. The darker lines are the more recent years. But with this other one, you can't say that. You can't say like the more green lines or anything. You just have to look at the line, look at the legend, look at the line, look at the legend, look at the line, look at the legend. But if you use luminance, it's much more readable, and patterns would pop out. That brings me to this idea of color ramps, where you can use a multi-hue color ramp. Like Veritas is very popular because it's perceptually linear. I mean, which means it varies consistently in luminance. So even if you were to convert the resulting visualization to grayscale, to make it black and white, it would still be readable. And I think that's something I love to strive for. I love this phrase, get it right in black and white. Because if you get it right in black and white, you could print it out, or somebody could photocopy it, and the visualization would still be readable. It has an element of robustness to the product. But you can also use hue to reinforce the luminance, which really is a great approach. And that's what Veritas does. See, it starts a little purple, then it goes into the blues and the greens and the yellows, all the while maintaining this upward luminance shift. But Turbo, on the other hand, it goes from dark to light and then back down to dark. But when it goes back down to dark, the hue is significantly far away from the original hue. So it really is a case-by-case basis to determine, is this readable? Does it work for a particular case? But if you use something like this that's not perceptually linear, it goes up in luminance and then back down in luminance. If you were to build something with this and then convert that to black and white, you would lose readability, because you wouldn't be able to determine if something's on one side, one end, or the other end of this. And so, yeah, for using color to represent quantitative attributes, I would recommend just varying in luminance, which is what these first color ramps do, or using a perceptually linear color ramp like any of these here. This one here is sort of the mother of all slides, again from Tamara Winsner, and it lays out the different channels. And on the left, over here, You've got the channels that work well with magnitude or ordered attributes. So ordered or quantitative attributes, these work extremely well. But then you've got on the right the identity channels that work well with categorical attributes, including hue. And then the ones that are most effective are at the top. So position reigns king, reigns supreme. Position is the most powerful. And then as you go down this list, it gets less and less effective at presenting the data. So now what I'd like to go into is a little exercise where I'd like you all to make some sketches. So based on the data that you've brought to the table, your analysis of the attribute types of that data set, and your tasks and questions that you want to be able to carry out, I'd like you to sit down with a pen and paper and actually make some sketches.